Hello, welcome all. Myself Kiran. I am from Department of ISV SVCE. Today we will learn about curve fitting. Curve fitting unveiling the hidden patterns. That is, we will reveal the hidden patterns from the curve fitting. And I had given a simple diagram where in the forest a road is passing, and we can assume the concept of the curve fitting with the help of this diagram, where uh, while building the road, we add some constructing materials. Like one of the example is stone. We can assume this as a data and the road as a curve, and we will study about this in the further slides. And first, let us see the outline. Introduction to curve fitting, types of curve models, curve fitting process, data collection analysis, model selection, adjustment parameters, tools of curve fitting, real life examples, and we end the session with the conclusion. First, let us see the introduction of curve fitting. And what let us see what is meant by curve fitting. The curve fitting is like finding a perfect puzzle piece to match the shape of the scattered points on the graph. That is, on a graph, we will be plotting some of the points, and we will be joining these points to get the curve. That's what is meant by the curve fitting. And let us see the importance in the various fields. And there are lot of fields where the curve fitting is used, and one of the most and in where it is used mostly is in the field of science, business, etc. And the main objective is to uncover the hidden patterns in the data and use them to get to guess what might happen in the future. That is, we can think of use of the curve fitting in the stock market, where when the stock market may crash, when the stock market may rise up. With the help of the curve fitting, we are able to predict the future of the we were able to predict the future of the stock market. And let us see the type of the curve models. And the linear curve, that is when we plot the points on the graph, and when we join them we get the straight line. That is, this is one of the example of this is called linear curve. And example is, imagine plotting how much you saved in a week, and the line connecting your points would be a linear curve. And let us see the second one, that is polynomial curve. Polynomial curves can be also called as bending curve. And curving your line to fit your data better. And uh, and the second thing is, uh, that is when we uh, plot the points on the graph, and when we join them we get a bending curve. That is, we get a polynomial curve. And the example practical example of this is, when tracking the height of the growing plant, and I had given the graph of the polynomial curve. This is how the polynomial curve looks. Okay. And let us see the exponential curve. Exponential curve is nothing but a curve which grows very rapidly. That is, the slope is very high. That is, in the less amount of time, the curve grows very rapidly. And where we can see this type, where we can see this, we can see this in the bacteria, that is multiplying in the petri dish. And I had given a diagram of the bacteria where it multiplies very rapidly. And this is one of the example of the exponential curve. And let us see the logarithmic curve. Logarithmic curve is exactly opposite to the exponential curve, where the slope decreases very rapidly. And one of the best example for the logarithmic curve is where the smartphone battery draining out very slowly at the first, and then it more quickly as it close to the empty. That is, as we see that as we see when the mobile is fully charged, the battery drains that much not. But when the battery charge is getting drained out, at the that is at when it become 10% or 5%, it drains very fast. That's what it says. And the curve fitting process. Curve fitting process is nothing but how we make this curve to fit in our data. That's what it means, the curve fitting process. First step is data collection. We have to collect the data. That is, we have to collect these points in order to plot on the graph. And model selection. That is, once we plot these points on the graph, we will be come to know by seeing it only which type of model we'll get, that is linear, logarithmic, or exponential, etc. And once we choose the model that can be linear, logarithmic, etc., and we'll be adjusting the parameters so that the curve can fit perfectly in the data points, and we will be evaluating this so that mm, so that there is no further mistake. And and we how we evaluate with the help of tools like MS Excel, Python, libraries, etc. Okay, and next, the data collection analysis. Let's talk about getting the right puzzle pieces. That is like we are getting the right puzzle pieces and the high quality data. And when suppose you are making a cake, we have to use high quality ingredients in order to make a good cake, right? That is, and similarly, we have to get the accurate data and reliable data in order to get the best curve fit. That is, so according to the data, we have to get the correct curve fit. Okay, and visualizing the raw data before we start fitting this curve. It's smart to look at our data points, picture them as dots on the graph. Seeing how they are spread on helps us to decide which type of curve might be fit fit best. Just like arranging the puzzle pieces before we start solving. That is, once we plot the graph, we'll be able to visualize it, right? Whether it comes under the linear model or exponential model, etc. By visualizing the raw data, to some extent we can predict which type of curve we will be getting. So it is very essential to visualize the raw data. Okay, then model selection. Choose the right puzzle pieces is very important. Balance between the underfitting and overfitting. If our curve is too simple, that is underfitting, and it won't match well. If it's too complicated, that is overfitting, it might match too closely and not work for new data. That is, it should not. There should balance between the overfitting and underfitting. That's what it says. And guidelines for choosing the models. Think of it choosing shoes. You should pick the pair of you should pick the pair that fits comfortably, right? Similarly, we choose a curve that fits the data nicely without being too tight or too loose. It's about finding the sweet spot. That's what it says. And adjustment of the parameters. Adjustment of the parameters means we have to adjust the curve in order to hug the data. That is, imagine you have a rubber band, you can stretch it to a different length and shapes. Okay, and in the curve fitting, we have to similarly stretch the parts of the parameters that we can change by stretching or squeezing them. That is, in order to fit the curve perfectly in the data, we are adjusting some of the parameters. That's what it says. We have to do this sometimes so that we get the exact results or the best results. Okay, and there are some of the real life examples. As I told earlier, we are using the what is that we are using the curve fitting application in the stock market. When it rises, when it declines, etc. Okay, with the help of the curve fitting, we are able to predict the stock market trends. And in the population growth, and we are able to predict how much the population may grow in the future, how much the population may decrease in the future. With the help of the curve fitting, we are able to predict this one also. Okay, and the scientific data. Scientists use the scientific data, that's the scientists use the curve fitting data or the curve fitting to make sense of their experiments. Okay, visualize it as connecting the dots on a graph to see when the things are heading. It's like having a crystal ball for numbers. And tools for curve fitting. Okay, there are some of the tools like example, Excel, Python libraries, MATLAB. As we know, Excel, it's user friendly, and it helps us to do basic curve fitting. Okay, and in the Python libraries, that is, Python is nothing but a programming language, and we have a lot of libraries in it. And one of the Python libraries, NumPy, and it is used to make curve fitting super powerful and flexible. Okay, and matlab is like a scientific toolbox. It's perfect for researchers and engineers. And the conclusion, And let us wrap it up. The curve fitting is like finding the perfect puzzle piece for your data. Okay, and we have different shapes like straight line curve, or curvy lines, curvy ones for different data patterns. That is, once we plot this data, then we are able to tell under under which category the curve fitting may fall. That is under linear model or exponential model, etc. Okay, based on the data, what we put in the graph, on that we are able to predict those things. Okay, the process involves collecting data, choosing the right curve and adjusting its settings and checking how well it fits. Okay, and balance is key. We don't want to too simple underfitting or too complicated. That is, once we fit the curve, we do some adjustments so that it fit at the best. Okay, and there are some of the tools we use in curve fitting. These are MS Excel, Python, and the MATLAB. In the future, machine learning will take the curve fitting to new heights. Okay, and this is one of the future trends, where the machine learning will take curve fitting to new heights. And thank you. And if you have any doubts, feel free to write comments in the comment box. I will be there to assist you. If you have any doubts, you can write them. I will answer at my best. I hope you enjoy the session. Thank you.